How does Keras support recurrent neural networks? Have you ever wondered how Keras makes working with recurrent neural networks easier? Let's break it down in a way that's easy to grasp. Keras is a user-friendly framework that provides high-level application programming interfaces for building, training, and deploying recurrent neural network models. This means you can get started without needing to dive into complex code. Keras offers specialized layers designed specifically for handling sequential data. These include Simple Recurrent Network, long short-term memory, and Gated Recurrent Unit layers. Each of these layers helps capture the temporal dependencies in data, which is essential for tasks involving sequences. When you create a recurrent neural network in Keras, you start by defining the number of units or neurons and the input shape. The input shape usually consists of the number of time steps and the features for each step. For instance, if you add a simple recurrent network layer, it processes data one time step at a time. This allows it to maintain an internal state that remembers information from previous steps, making it perfect for tasks like predicting time series data or modeling language. Now, if you need something more advanced, Keras has you covered with long short-term memory and gated recurrent unit layers. These layers tackle the challenges faced by simple recurrent networks, such as the vanishing gradient problem. They use gating mechanisms to control how information flows, allowing the network to remember details over longer sequences. Implementing an LSTM layer is as simple as adding it to your model and specifying the number of units. Keras handles the rest. Keras also allows you to stack multiple recurrent layers or mix them with other types of layers, like dense layers. This flexibility is key because real-world data often comes in sequences of varying lengths. Keras can manage these differences effortlessly, which is crucial for practical applications. In the real world, Keras recurrent neural networks are widely used in fields like natural language processing, speech recognition, and time series forecasting. For example, you can create a language model by combining an embedding layer with an LSTM layer. This setup helps the model learn patterns in text and generate new sentences that mimic those patterns. Keras makes recurrent neural networks accessible by simplifying the underlying complexities. This is important for ethical artificial intelligence development, as it allows practitioners to prototype and test models quickly. This encourages experimentation while keeping an eye on model behavior and potential data biases. Additionally, Keras works well with productivity tools that help with training, evaluating, and deploying models. This is especially useful when working with applications like chat generative pre-trained transformer or image generation models like DALL-E and Midjourney, where sequential data processing is often involved. To sum it up, Keras supports recurrent neural networks by providing built-in layers for sequential data, flexible input handling for varying sequence lengths, and easy model building through its application programming interfaces. This makes Keras an essential tool for anyone looking to work with recurrent neural networks in artificial intelligence and machine learning.